Okay, so now we're going to use this solution of calcium to prepare our standard solutions for a calibration curve. So if we think about what we're trying to do, we're trying to make a calibration curve, right, where we've got concentration of calcium in ppm on the x-axis, and we've got response, and in this case, for the atomic absorption instrument, that's response in terms of absorbance on the y-axis. And we know that this concentration for calcium needs to be between 1 and 10 parts per million, and that's because that's the best linear range for the instrument, and that's discussed in the lab manual. So you're going to make solutions from 1 to 10 ppm. Now, the reason that this part of the lab is so challenging for people is that we tell you that you need to make 5 solutions of calcium between 1 and 10 ppm, and we tell you, or we help you figure out what you're going to start with, but we don't tell you exactly how you're going to make those solutions, okay? And so the important part, or the things that you need to know, is that you must use volumetric glassware, that you need 5 solutions, okay, and that the solution should be relatively evenly spaced between 1 and 10. Okay, so the challenge here is that you have a big selection or multiple options for your volumetric pipettes, and you have multiple selections for your volumetric flasks. I guess another thing that I should mention is you probably want to have greater than 100 mils of each solution. Okay. So we give you flexibility here, and I think that's what's so challenging about the lab, which is one of the reasons that I'm making these videos. So what you can do is we're going to use a standard M1V1 calculation to do this, but you can use a chart to help you determine which are going to be the 5 concentrations that you need. Okay? And the way that you make this chart is by drawing a grid. Okay? And in this grid, you're going to have your volumetric flasks up here, and your volumetric pipettes here, okay, in this column. And so what you're going to do is you're going to do the M1V1 calculation using these 2 values and the concentration of the stock solution that you have, and then you're going to calculate what concentration you would get for each of those combinations. So your volumetric pipettes are 1, 2, 3, and 5. And your volumetric flasks are 100, 250, 500, and 1000. Okay. So, and the stock that we're going to use is this 601.2. So if I could draw these, this calculation out by saying M1 V1 equals M2 V2, okay, where M1 is my stock solution, which is equal to from the last video, right? So M1 is my stock solution, V1 is my pipette volume, V2 is my flask volume, and then I'm solving for M2, okay? So M2 is equal to M1 V1 over V2. And so if we draw this out for the first, we see that M2 is equal to 601.2 times 1 milliliter over 100 milliliters. Okay. And so the milliliters cancel, and basically we're just dividing 601.2 by 100, right? And so this would end up being 6.012 ppm. Okay? And you can see a couple things about this. For the one thing, the units we want are ppm. And so even though this is milligrams per liter, if both these units are in the same units, milliliters, then they cancel out, right? And so then we're left with the units that we want, which is ppm. So we can fill out the rest of this chart, which I'll probably do outside of the video, and then I'll come back and we can discuss how you would choose the different which ones to use.